Okay, guys, so without any waste of time, let's now move to question 2.1.3. So before we read the question, there's a mini statement given there. I hope you can see the kinetic frictional force between the block and the surface of the inclined plane is 20.37 Newton. Guys, I just want to take this opportunity to indicate to you that you can find these question papers. We post these question papers on our Telegram channel. So you can just, on your Telegram account, search for solving exam papers. That's where you can join and access this question papers. So let's move on. So now let's have a look at the question 2.1.3. The question says calculate the magnitude of force P. I'm not sure if you noticed something from the previous statement that I've just read. We are given the kinetic frictional force between the block and the surface of the inclined plane, which is 20.37 Newton. So now, guys, the question wants us to calculate the magnitude of force F. So every time, guys, every time when I'm requested to calculate the magnitude of the force, I always think of this formula, especially that I was just given the frictional force. So I always think of this formula. I'm sure you are familiar with this formula, which is F net is equals to ma, mass multiplied by acceleration. So this is the general formula that you should always know by heart. And you might find that this formula comes from that definition of question 2.1.1, but I won't go deep into that. I think for now we just need to focus on this question. But if you can just at the end of this lesson go back to question 2.1.1, you will realize what I'm talking about, that this formula actually might be coming from that definition. So it's more like by knowing the definition, you automatically know the formula. By knowing the formula, you should automatically be able to define Newton's first law. So this formula, we can extend it to suit this particular situation. So remember, guys, the word net refers to total. So that means the total forces acting on an object are equals to the mass of that particular object and the acceleration of that object. And remember, guys, remember the acceleration is equals to velocity final minus velocity initial over time. There's something which was interesting. I'm not sure if you're with me when we started with question 2.1.1, where we emphasized the fact that in the statement they mentioned a constant speed in capital letters. I want you guys to pay attention to this. Remember, the formula says F net is equals to ma, and a refers to the acceleration of an object which is in motion. So obviously that means if the acceleration is constant, it means the object is moving at a constant speed. What does it mean when an object moves at a constant speed? It means its speed or its velocity is the same throughout. From the initial point to the final point, its velocity or speed remains the same. Suppose a car was traveling at 40 kilometers per hour or 40 meters per second. It doesn't matter, whichever unit. So that means if a car is traveling at 40 kilometers per hour at the initial point and at the final point is it's still traveling at 40 kilometers per hour. When we make use of that information on this formula in order to calculate the acceleration of that particular moving object, it means it's moving. This is the initial point, this is the final point. It's moving at 40 kilometers per hour. This is the velocity initial of the object, and it traveled that particular distance. Let's say maybe it took 20 let's say it took 1.5 hours to travel from point A to point B. Our point A is the initial point, our point B is the final point, where we know its final velocity, it was still 40 kilometers per hour. So if we make use of this information and substitute on that formula, this is what we get. So we get 40 minus 40. Remember, final velocity is 40, initial velocity, it was 40, over, it took 1.5 hours. When we proceed with this formula, we know 40 minus 40 is equals to 0 over 1.5. So what does it mean? Anything, when you divide 0 by whatever number, it's equals to 0. We therefore have 0 per square seconds, which is the SI unit for the acceleration. So in other words, guys, it means for the fact that the velocity or the speed is constant, the influence of constant speed on this formula is the fact that it makes the acceleration to be 0. So I'm not sure if it makes sense, guys, but I'm 100% sure that if you can try to replay this part, you will have a better understanding of exactly what I'm trying to explain. Because, you know, sometimes when you understand things better, you tend to just assume that they are as easy as you interpret them, only to find that someone might be having a different question which might guide you on how to provide an explanation, of which I assume you will assist with that by commenting on the comment section in case if it doesn't make sense. But if it does, I'm very much happy that I'm able to easily explain to you guys so that you understand exactly what's going on, because I don't want to leave you guys behind. So I think at this stage we can now proceed. So in short, because the speed of object P is constant, that means acceleration is 0. That's what I was trying to explain with the whole of this in short. So now I think we can now proceed. So it obviously means in place of A, we already know it's 0. And again, the mass, we know we are given the mass is 8 kg. Okay, so now let's move on with the question. So remember, I've just indicated that F net refers to the total force. So now we just write all the forces acting on object P. What forces do we have? I usually start with the force which is being applied. So I've got the force, which is the applied force, plus I've got the force of friction. So this is the format that I usually follow. I start with the applied force followed by the frictional force. From there, that's when I add the force of gravity, and I can then equate it to MA. So I'm not sure if so far we're still together, guys. So I haven't actually gone deep into answering the question. I've just been explaining that formula, and what I've just done now is just to expand that F net. So the F net is equals to all the forces acting on an object which is given on the statement. So I think, let me see. I think we can now, move on with the calculation part. And again, you might find that this formula, it's expanded, but then now we need to expand it again so that it suits this particular question. So let's see. So far, what have we got? We've got the A. We know the acceleration is 0. We've got our mass, which is 8. We also, do we have information for G? That's where we might need to expand the formula. So I'll just indicate here that it's mg, it's mg sine angle. I will explain to you guys that part. So do we have the m? We do have the m. Do we have the g? We do have the g. It's always given. It's 9.8. The angle, are we given? We do have the angle. So that means we are sorted with regards to Fg. Do we have the force of friction? We're just given the force of friction. Do we have the F? The question is no. So F is the applied force, which is what the question wants us to calculate. So by the look of things, it seems like we are done with this question. It's just a matter of plugging all the information that we have. So I'll only need you to pay attention to the values that I'll be plugging so that you have an idea of where those values are coming from. So let's now proceed with our question. Remember, guys, we have our force applied, which is a positive F. So what I mean by that, remember on this question, the force is being applied in that direction. So I take towards that direction or towards the east as positive. So that means any force acting against the applied force, it's a negative force. So from this formula, have we got forces acting against the applied force? We do have. So we've got a force of gravity which is acting against the applied force. So in brackets, let's substitute the force of friction. We were given as 20.37 newtons. Remember, guys, everything substituted on this part of the formula, it's a force, which means its unit is in Newton. So you shouldn't be substituting by mistake something which is not a force. Let's say, for instance, for some reason you forget that the force is 20.37, you substitute 8. Excuse me. So just ask yourself, what is that 8? Is it a force? Is it a mass? Is it a velocity? What it is? So you should ask that question, say, what exactly is that magnitude that I substituted on that formula? So again, is the force of gravity acting in direction of the applied force or in the opposite direction? You can see, guys, it's obvious from the statement. The applied force is acting, it's more like it's acting upwards. Because obviously, remember, they indicated that it's this object P, it's moving up an inclined surface. So it's basically moving upwards at that angle of 30 degrees. And we know force of gravity is exerting downwards. So that means the force of gravity is acting in the opposite direction. I'm sure you fully understand that part. So that means it's acting against the applied force. It's therefore m. What is the mass of that object? It's 8. What is the gravitational acceleration? It's 9.8. Sine of which angle? we are talking about the angle of 30 degrees. So that's where you substitute the 30 degrees angle. So which means, in short, I'll just refer back to this original diagram. So that means, guys, this angle, you use it on this formula of mg sine, let's say it's theta. It's angle theta. So you use this angle to assist you when it comes to force of gravity. So I think that information will actually help you guys to tackle some of the questions. So we have substituted everything, so now it's just a matter of equating it to the right side of the equation. So what is our m? Our m is 8. What is our a? Our a, which is the acceleration, the constant acceleration, at 0. So can you see, guys, we've got all of this, you move it, it's plus this, you move it, it's plus this. So all of that will be equals to our force, which is what the question wants us to calculate. So let's see. We've got obviously 8 and 0, it's equals to 0. Then you add your 8, 9.8 sine 30 plus 20.37. So the answer that we get is the force which is applied. Can you see, guys? So that means the applied force is 59.57 newtons. So I'm confident that so far you understand exactly what's going on with regards to this question. Otherwise, guys, you know exactly what to do. You comment on the comment section. If you've got a suggestion, you suggest. If you've got a question, you just post that question. So I will address those questions. So I think let's see. Okay, before I say let's move to the next question, guys, obviously we have to mark this question so that you see exactly where at a marking center they'll give you the marks. You know what I like about physical sciences, guys? We get free marks. Look at where you score your free mark. That's where you score your free mark. You just score a free mark by copying the formula from the formula sheet. By just writing it down, you score a mark. Let's see where you score. Let's see where you score additional marks. Remember this question, it's allocated 5 marks. So obviously they will give you a mark there for correct substitution. They will also give you a mark there for correct substitution. They will also give you a mark there for correct substitution. Can someone there at the back at the corner tell us where are we scoring the last mark? Which is an obvious matter. This is where you score your last mark. So I think, guys, you enjoyed this lesson as much as I did, and I think you are now ready to move to the next question, which I assume it also should be very much easy. I'm not sure if this question that we've done was easy or difficult, but I'll just hear from you guys. If you wish, or if you suggest that we tackle some more questions on this chapter, just indicate. Then I'll make sure to check from the past papers and see if I can find similar questions that we can treat. think you guys are enjoying these lessons as much as I do. Otherwise, without any waste of time, guys, I think we can now move to question 2.1.4, of which I'll just create a special video because I notice we've already spent a lot of time on this question. Okay,